Find the equation of the tangent line to the curve 3 to the power of x at 2 and 9. Okay, before I go ahead and show you how to do this, I wanted to point out that there are only 2 weeks left in the Maths Countdown series, so we are right near the end of this series, so make sure you stick around until the end. Okay, so in order to find the tangent line to a curve at a particular point, we need the gradient of the curve at that particular point, as well as the given point, its coordinates. And so we've been given the coordinates, but we need to find the gradient at the particular point. And gradient is represented by the derivative. So the derivative is a function of the original function's gradient. So we have to derive 3 to the power of x in order to find its derivative so that we can substitute in 2 to find its specific gradient at 2. So if we had a function y is equal to 3 to the power of x and we were to derive this, the way that we do this is by taking the natural log of both sides. So we take, this is logarithmic differentiation. So we have the natural log of y is equal to ln 3 to the power of x. But because of our log laws, we can take this x out as a coefficient of ln of 3. Then if we solve this implicitly through implicit differentiation, we get the derivative of the natural log of y in terms of x is 1 over y times by dy dx. And the derivative of this in terms of x is just the natural log of 3. So therefore, the derivative of y in terms of x, which is what we're trying to solve for, the derivative of y in terms of x, all we have to do is multiply both sides by y. So if we multiply this left-hand side by y, we're just left with the derivative. And if we multiply this right-hand side by y, it's the same thing as multiplying the right-hand side by 3 to the power of x. So we have the derivative of the function. But now we need the derivative of the function at x equal to 2. So we need to substitute in 2 into this formula. So dy dx at 2 is going to be, at x is equal to 2, is going to be the natural log of 3 times by 3 to the power of 2, which is just 9 times by ln of 3. Okay, so the standard practice to find the tangent line to a particular slope at a given point, we use the function y is equal to mx plus c, because the tangent line is linear. So where m represents our gradient, c represents the constant that shifts this line. So we've worked out our gradient to be 9 natural log of 3. So we have y is equal to 9 ln of 3 times by x. And then for our constant c, we've got to substitute in 2 and 9 for our x and y so that we can solve for c. So if we sub in now 2 and 9, then what we get is 9 is equal to 9 ln of 3 times by 2 plus c. And solving for c, we get 9 minus, and now 2 times by 9 is 18, so it's minus 18 natural log of 3. So expressing our final solution, the tangent line to the curve 3 to the power of x at 2 and 9 is going to be y is equal to our gradient m, which is 9 natural log of 3, times by x, plus our constant c, which is this. So plus 9 minus 18 natural log of 3. And that is the tangent line to the curve 3 to the power of x at the point 2 and 9. I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. Thank you.